Good morning and Jai Hind children. We are discussing the chapter Physical and Chemical Change in Chemistry. And in previous class, we have started the exercise C. Exercise C. Is it? And this book exercise C is which kind of exercise? It is short answer question. Short answer question type of questions are there, and out of this exercise we have discussed the answers of four questions. Is it? Four questions we have discussed. Now today we will discuss the next question, that is question number 5. But before starting the question number 5, I hope that tell me that you all understood well about the answers of four questions of sort which we have discussed in previous class. Is it? Everyone? Very good. Now let's start. Come to the question number 5 of short exercise, short question answer. And the question number 5 is there: when a combination reaction, as we have discussed in the chapter the combination reaction. So here you have to write that what is combination reaction, and you have to give one example of it also. Get it? So different types of reactions we have discussed: combination, decomposition, single displacement, double displacement reaction, oxidation and reduction reaction. So here in this question, you have to write down what is combination reaction. Children, remember that the combination reactions are what? When a compound is formed from its element, when the different elements are going to combine together to form its compound. Okay, or you can also say that from simpler substances, what is going to form? A compound is going to form. So such reactions are known as combination reaction. Get it? And simply we can represent the combination reaction as A plus B. They both react together chemically and forms AB, form a compound AB. Get it? So this is the general equation of combination reaction. Now here you have to write an example also. So in the example, we will write the example of magnesium. The symbol of magnesium is Mg. The symbol of magnesium. When this magnesium element is going to react with another element, say that oxygen. Symbol of oxygen is O2. Get it? So magnesium and oxygen, they both react chemically and forms a compound, that is magnesium oxide. Okay. So actually this magnesium oxide is made up from these two elements, element magnesium and element oxygen. They are going to combine together in this compound. That's why such type of reactions are known as combination reaction. Get it, everyone? Now come to the next question number 6. And the question is, when is a substance said to be reduced in a chemical reaction? The question is, when is a substance said to be reduced in a chemical reaction? When any chemical reaction is going to occur, so at which time we can say that a substance is going to reduce? So there is two conditions: either loss of oxygen or add of hydrogen. Is it? So you can write the answer as a substance is said to be reduced in a chemical reaction when it loses oxygen or adds hydrogen. Get it? Then it will termed as, it will what? Termed as what? Reduced. It will consider as reduced. Get it now? And one more thing that you must have to remember, when a substance is said to be oxidized in a chemical reaction, so that time what you will write? A substance is said to be oxidized in a chemical reaction when it adds oxygen or lose hydrogen. Get it? So then it will what? Termed as, considered as oxidized. But in the question it was asked that when it is termed as reduced, so when the oxygen will lose or hydrogen will add, then the substance will termed as reduced. Get it? Understood everyone? Now come to the next question number 7. And the question is, what is crystallization? Children, here you have to write the definition of crystallization. Remember, we have discussed the two processes in the chapter by which soluble solid in liquid or in water can be separated. Is it? And the two method was, the first one evaporation and the second one crystallization. Get it? So here you have to define the process of crystallization. So what happened in crystallization? We obtain the crystals. In the process of crystallization, we obtain the crystals of common substances like salt, like sugar, like alum. Okay, what we obtain? The crystals of salt, alum or sugar. And how it is obtained? It is obtained from the solution of these substances, like from the solution of salt in water, solution of alum in water, solution of sugar in water. Okay, so from such solution, as we are going to obtain the crystals of these solids, so this process is known as crystallization. Get it? The crystallization process. Right? Now come to the next. A. Okay, and the question is, what is a supersaturated solution? What is a supersaturated solution? So children, remember that in the process of crystallization, we have discussed that when the solution of substance prepared in water and as much as solid get added in water, it is. So that is known as saturated solution. And after heating the saturated solution, we can add some more solid in it. We can dissolve some more solid in it. Okay? So that time that saturated solution is known as supersaturated solution. What is the difference between saturated solution and supersaturated? Saturated solution means that at normal temperature in water, the amount of solid get dissolved. Say that amount of salt get dissolved. Okay. And now no more salt can be dissolved. So that time that solution is simply known as saturated solution. Now heat this saturated solution. So when you will heat it, what will happen? What will happen? Some more solid can be dissolved in it because solubility increases at more temperature. Temperature if increase, solubility increase. Okay, understood? So that is why if you will heat the saturated solution, so you can add, you can dissolve some more salt in it. Okay, now that time it will termed as supersaturated solution. So then you have to write that what is supersaturated solution. So children, simply supersaturated solution is, it is the state of a solution which is unable to saturate any extra solute in the solvent. Means now we are not capable to add or dissolve some more solute. Okay, so that state of solution is known as supersaturated solution. Okay, even after heating, we cannot add more solute because it's already heated. So that condition, that state is known as supersaturated solution. Get it? Understood? So this one is all about your short answer type questions. And you have to write the answers here in just one small paragraph or 2-3 lines. Understood now? Now, come to the next exercise of the book. That is long answer question. Answer questions. The answers of these questions you will write in a paragraph, not just in one sentence or two sentences. Alright? Because they are the long questions. Okay? So come to the first question. And the question is, discuss the methods by which rusting of iron can be prevented. Understood the question? How we can prevent the rusting of iron? How we can stop the process of rusting of iron? So simply children, you have to write here the methods, the ways, the process to stop the rusting. Is it? Rusting can be prevented by not allowing the iron to come in contact with moisture and air, because moisture and air, these are the two what substances which are responsible for rusting. Now, these are the two factors by which rusting occurs, and if we not allow these two substances to go on the surface of iron, so what will happen? Iron will not rust. Is it? Rusting process will not occur. So there are different ways to stop the moisture and air to go on the surface of iron. And the first way is by coating a what? Paint or grease on the surface of iron. If we apply a coat of paint or if we apply a coat of grease on the iron, so what will happen? That layer of paint or grease will not allow moisture or oxygen to go on the surface of iron, and our iron will not get rusted. Get it? So the process of rusting will get prevented now by this method. And the second method is by depositing a layer of zinc or chromium on the iron. If we deposit a layer of other metal like zinc metal or like chromium metal on the surface of iron metal, so what will happen? Also iron will not rust. Rusting will not happen, because zinc and chromium, these are the metals which not get rusted. They not react with oxygen and moisture, and rusting will not occur. So that is why these metals are going to apply it on the surface of iron. You must have seen the water pipes. Water pipes, they are made up of iron, but they have a shiny layer. Is it not? Actually, that is the layer of zinc. And because of the presence of that zinc layer above the pipes, they not get easily rusted. Okay, you must have seen your bathroom taps. They are shiny. Is it not? But they are made up of iron, but there is a layer, thin layer of chromium or nickel above the iron. So that is why they not get rusted. Okay. So this is also one of the method to apply a layer of other metal like zinc metal or chromium on the iron to prevent it from rusting. Got it? Understood? Everyone? So you can prevent the iron rusting of iron by two methods. First, by applying paint or grease on the surface, and second, by what? Depositing a layer of zinc or chromium on iron. So we can prevent the rusting of iron. Okay. Now come to the next question number 2. And the question is, which gas is given off when dilute hydrochloric acid is added to calcium carbonate? Children, just go through the question. when you are going to add dilute hydrochloric acid to calcium carbonate, so which gas will come? And how will you taste this gas? How you will find out that which is this gas? Gas is coming, but how we can find out which gas is this? Hit it and write the chemical equation for both the reaction. Understood the question? Three parts are there in question. In first part, you have to tell that what? Which gas will come? Okay. Second, you have to write its chemical equation, and then you have to write that what? How you can taste the gas, coming gas. So, children, simply when the dilute hydrochloric acid is added to calcium carbonate. Formula of calcium carbonate is calcium carbonate CaCO3. CaCO3. This is the formula of calcium carbonate. And when we are going to add which acid? Hydrochloric acid. And the formula of hydrochloric acid is HCl. Is it? So what will happen? Three new substances will form, three products will form. The first product is calcium chloride, and the formula of calcium chloride is okay. So this is the first product, calcium chloride. Second product is water, and the third product is a kind of gas, and that gas is carbon dioxide gas. Okay, so this is the chemical reaction or equation by which we can show that when calcium carbonate will react with hydrochloric acid, it will form calcium chloride, water, and a gas will come, that is carbon dioxide gas. So you have identified here this is carbon dioxide because I have written CO2. But suppose this equation is not going to written, only it is written a gas is coming. So how you will identify this? The gas is carbon dioxide. So there is a test, simple test to find out that the gas is carbon dioxide or not. Okay, by having another simple reaction of carbon dioxide. And what we will do? The gas which is coming here, pass this gas or collect this gas in a test tube and just apply the thumb on the test tube. Gas get filled and now add calcium hydroxide in it. What you will add? Calcium hydroxide, and the formula is CaOH twice. CaOH twice. This is the formula of calcium hydroxide. So when the calcium hydroxide get added in that coming gas, okay, from the first reaction, and after it you are going to observe, what you are going to observe? A white milky solution. What you are going to observe? A white milky solution. And when this white milky solution is kept for some time, so some white precipitate is going to deposit. White precipitate is going to deposit in the bottom, and above it water is present, liquid is present. Okay? So actually that white precipitate is calcium carbonate, and the formula you will get it. Calcium carbonate will deposits in the bottom and water is present above this precipitate. This proves that the gas is carbon dioxide only. Because this reaction will not occur with the gas in the other gas like oxygen, like hydrogen, then this reaction will not occur. If this reaction is going to occur, white precipitate is going to form and water is going to form. So you can say that the coming gas is which gas? Carbon dioxide. So this is the way by which we can test about the gas, that the gas is carbon dioxide. Understood? Everyone? Huh? So you have to write both the chemical equations, reactions here, and you have to give your answer also. Okay. Now come to the next question number 3. Okay. And the question number 3 is, explain the steps involved in preparing magnesium hydroxide. What you have to write here? Question number 3. You have to write all the steps which are involved in which process? In the process of preparing which compound? Magnesium hydroxide from metal magnesium. How from the magnesium we can prepare magnesium hydroxide? So you have to write all the steps. So in the first step, what you will do first? Take a small piece of magnesium ribbon. Magnesium ribbon is available in labs. Okay, it is thin ribbon-like structure. So take a small piece and then clean its tip with sandpaper. What you have to do? Clean the tip of magnesium ribbon with sandpaper. Sandpaper, you know now? Huh? Alright. So with the help of this paper, clean its tip and hold it with a pair of tongs and bring it near a flame. Get it? What you have to do? You have to bring that piece of magnesium ribbon near the flame of candle. Get it? So this is the first step. In second step, what will happen when you will bring it near the flame? It will burn. Okay. And how it will burn? It will not burn like candle. It will burn with a dazzling white flame. Dazzling white flame will come. Okay, when this magnesium ribbon will burn. And at last, when whole magnesium ribbon get burned, what you will get? You will get a white ash, white powder. As the your paper piece of paper burns, you get the black ash. Is it now? So when the magnesium ribbon will get burned completely, you will get white ash, white powdery ash. Get it? And that white powdery ash is what? Actually, this white powdery ash is magnesium oxide. Okay, so you can write the reaction as when the metal magnesium is going to burn, and the burning process will occur only in the presence of oxygen. When the magnesium will burn in the presence of oxygen, it will form a white ash, and that white ash is magnesium oxide. Okay, understood? Now, in the third step, collect this all white ash, collect it on the paper, that powder, white powder, and then mix it with a small amount of water. Collect this ash, put it in the test tube, and put few drops of water and shake it. Mix it. Get it? In the test tube. And after it, what you will observe? That ash get dissolved in water. Ash will dissolve in water and it forms what? Magnesium hydroxide. So you can write the reaction with this magnesium oxide, that white ash is going to mix with water, get dissolved in water and will form a new substance, that is magnesium hydroxide. Okay. These are the steps involved to obtain magnesium hydroxide from the magnesium. And it is two-step process. In first step, magnesium oxide will form, and then in second step, magnesium hydroxide. Alright? Understood everyone now? How this magnesium hydroxide is going to form by magnesium? Now, come to the next question number. And the question number 4 is a decomposition reaction is the opposite of a combination reaction. Decomposition and combination. Remember, these two types of chemical reaction. They both are opposite to each other. Okay? So explain with the help of an example. Means in this question you have to explain both the reaction or you have to differentiate both the reaction with one example. Get it? What two reactions you will differentiate here? You will differentiate combination reaction and decomposition. You have to differentiate. So simply the first differentiation, you can say the first one, this combination reaction is dominated by a general equation and the general equation is A plus it gives means the new compound will form and the compound will be A and D combination of it. And decomposition reactions are generally denoted by after the reaction gives plus P. So this is one of the difference between these two. Get it? And the example of this reaction is any example you can take in which combination is going to occur and decomposition is going to occur. For this one, I am going to take the example of hydrogen and oxygen. Hydrogen gas plus oxygen gas. They both are going to react together and form gas. Form water. Form water. They both are in which state? They are in gaseous state. And the product it is. So this is the example of combination reaction. Now, the example of decomposition reaction use the same one. When the water is going to decompose, so it breaks into hydrogen gas and oxygen gas. Hydrogen gas and so this is going to show that decomposition reaction. Here, the first difference. Now, the second difference that you can write as the combination reaction compound which is formed here is going to form from simpler substance. From these two simpler substance, this compound is going to form. No any third substance is coming here. No any extra substance is going to add here. Only whatever the simpler substance present, they both will combine and form the compound. Right? And in forming decomposition reaction, what happened? A compound breaks. This is the compound. And during the chemical reaction, it is going to break into what? It's going to break into two or more substances. So here in this example, this is going to break into two substances. In some other might in some other examples, it can break into three substances. So that will depend on the kind of compound which we have taken. So here in this example, we have taken water. So water will break into two substances. That is hydrogen gas and oxygen. Did understood the differences between combination and decomposition and the example also. Now come to the next, that question number question number 5. And the question number 5 is under which two conditions do decomposition reactions normally takes place and give one example of each. Children, here you have to write the two conditions, which is what? Used in decomposition reaction. When the decomposition reaction is going to occur, so this decomposition or breakdown will occur in what conditions? Okay, so two conditions are there and you have to explain them with the help of example. Okay, so the first condition is, what will be the first condition for decomposition? How a substance can decompose? Substance can be decomposed by heating. So what is the first factor? First condition? Heating. Okay, it can be decomposed. And the example for it is calcium hydroxide twice. The formula na? Calcium hydroxide when heated, so it will break into two substances, that is calcium oxide and plus water. Okay. So when calcium hydroxide heated, it decomposed into two substances, calcium oxide and so this equation, this reaction is a type of which reaction? Decomposition reaction. But this decomposition is going to occur when it will heat. If it will not heat, so this reaction will not occur. Okay, so heating is one of the condition. For which reaction? For decomposition reaction. Alright? Second condition for decomposition reaction is electricity, pass of electricity. When electric current is going to pass in some substances, they also break. Get it? And the example is when water, what happened? Electricity pass in it. So what will happen? It will break into hydrogen gas and oxygen. So this is an example of decomposition reaction. But it will occur only when electricity will pass. If electricity will not pass, it will not occur. Get it? So for the occurrence of these two decomposition reaction, these two conditions are necessary. The first one heating, second one electricity. Understood everyone? These all answers. So complete the work in your fair notebook and rest of the exercise we will discuss on next class. Get it? Okay? Thank you and have a nice day, children.